Now, it might look like this is essentially the same problem as the previous couple of examples, but this has something different than what we've done before. So that's why I'm asking this one in particular, because it is a separate category, or it's categorically different than the type we've done before. And the thing that's going to make this particularly a little bit of an issue is that 0. So if you like, pause the video now, see if you can find the values of the 6 trigonometric functions for the point p equals 0, 4. And then when you're finished, you can come back and see if I can match up with your work. All right, let's see how well I can do this. The point we have in question is 0, 4. All right. And so this is the angle. In fact, that's a right angle, right? We know how this is a 90-degree angle. 90. And so this is our value for theta. We still need x and y and r. You might think, well, there is no triangle here. Strictly speaking, we don't need a triangle. All we need are x and y and r. X I have, x is 0. Y we have, y is 4. We need to find r. You say, well, there is no r in the picture. You don't need r. Actually, there is. We'll adjust that later on. But all we need is r squared is equal to x squared plus y squared. You can find the value of r algebraically without reference to the picture. It turns out it is here. It turns out not only is this equal to y, it's also equal to r, but we'll get there. R squared is equal to 0 squared plus 4 squared, which is 16. And since we know we're taking the positive square root, it suffices for our problem to say r is equal to the square root of 16, which is 4. So we have x equals 0, y equals 4, and r is also equal to 4. And now we can find the x, y, r definitions. Sine theta is y over r, 4 over 4. Now, I've earlier said you do not need to simplify, and you really don't. But it's probably not asking too much to say that's equal to 1. If you leave it as 4 over 4, that's okay. But 1, this is probably not asking too much. Have a little pride. Cosine of theta is x over r. Well, x is 0. Again, you don't strictly need to simplify that, but it's probably not asking too much. 0 divided by 4 is 0. And then we have tangent, and that's y over x. Y is 4, x is 0. Now watch what happens here. 4 divide by 0. Remember that 4 divide by 0 is not allowed. Dividing by 0 is not allowed. 0 in the numerator is nice. That's how, oh my gosh, way back when I first took basic algebra back in 19... This is the stupid rule that, this is what we learned. 0 in the numerator is nice. 0 in denominator, don't. 0 denominator, don't do that. Denominator, this is undefined. Undefined, we will simply abbreviate that as UND. Undefined. Undefined. It has no value. There is no number. 4 divided by 0. Then, cotangent. Cotangent is x over y. There's no problem here. X over y is 0 divided by 4. 0 in the numerator is nice. That's equal to 0. Secant. Secant is r over x. R is 4. R is 4. X is 0. This is, let me get some space here. This is 4 over 0. Again, 0 in denominator, don't do that. This is undefined. There is no value. And then cosecant. Cosecant theta is, what do we have? That's y, r over y rather. R over Y is 4 over 4. And again, it's probably not asking too much to say that's equal to 1. And so what happens is this. If the angle in question, do you remember the word quadrantal? Quadrantal. An angle is quadrantal if the terminal side lies on one of the axes. If the terminal side lies on one of the axes. For quadrantal angles, some of these functions are going to be undefined. That comes into play with all the work that we do going forward. That's going to come into play. So that's why it's important to know the XYR definitions. If you don't know what is the reciprocal of undefined, it doesn't really make any sense. But the XYR definitions let you get the result you need. So there we have it. And if I had chosen, instead of 0, 4, if I had chosen negative 5, 0, some of them would have been slightly different, but the final results would have been similar, not the same, but very similar. If we had chosen a point over here, let's suppose we had chosen 3, 0, similar things would have occurred. Other function values would be undefined. And if we choose one down here, suppose we choose 0, negative 1, other function values would be undefined. So if the point lies on one of the axes, undefined values are liable to occur. All you need to do is use the XYR definitions as if they were just the base definitions, because that is what they are. They are the base definitions. Use the XYR definitions. Use X and Y to find R, and then plug the values in. Anytime you have 0 in denominator, don't do that. If 0 is in the numerator, that's nice. You get 0. So, the trigonometric functions, the 6 function values, XYR definitions, given X and Y, you can find R, and then find the function values. If the angle is quadrantal, then you may very well have, in fact, you always will have, some or other of these angles or function values are going to be undefined.